Study of different types of diode characteristics and its application. Objective: to draw voltage current VI characteristics of PN junction diode. To draw the voltage current VI characteristics of Zener diode. To construct the circuit and observe the wave shapes of half-wave diode rectifier. To construct the circuit and observe the wave shapes of full-wave diode rectifiers. Task 1. To draw the voltage current characteristics of PN junction diode. Objective: to draw the voltage current characteristics of PN junction diode under forward and reverse bias condition, and to determine cut-in voltage, reverse saturation current, and forward dynamic resistance. Theory: a PN junction diode conducts only one direction. It is an example of unilateral element. The VI characteristics of the diode are curve between voltage across the diode VD and current through the diode ID. When P-type anode is connected to positive terminal and N-type cathode is connected to negative terminal of supply voltage is known as forward bias. The potential barrier is reduced when the diode is in forward bias condition. At some forward voltage, the potential barrier altogether eliminated and current start flowing through the diode and also in the circuit. The diode is said to be on state. The current increases with increasing forward voltage. When N-type cathode is connected to positive terminal and P-type anode is connected to negative terminal of the power supply is known as reverse bias, and the potential barrier across the junction increases. Therefore, the junction resistance becomes very high and a very small current called reverse saturation current flows in the circuit. The diode is said to be off state. The reverse current is due to minority charge carriers. The required apparatus are shown in table. Circuit diagram. Now we will draw the circuit diagram for forward bias condition and reverse bias condition. Big device. Diode. Identification number 1N4007. Rectifier diode. Double click. It will add here. DC voltage source. Normal resistor. Double click. Potentiometer. How to draw? See your mouse. This source. Edit properties. Make a variable power supply. Edit properties. To observe voltage. DC voltmeter connect here. Then ammeter. You have to check the polarity. Load resistor. your mouse. You want to measure diode across voltage. Video. Edit properties. You can run your simulation. And supply voltage is 0. Diode across voltage is 0. Current also 0. When I increase voltage, this is supply voltage. This is diode across voltage. Current start flowing. This is circuit diagram for forward bias condition. 0 to plus 15 and ground. This voltage will come from project board, and this is VS supply voltage. This one is symbol for diode. This one is diode. Its identification number is 1N4007. It is written in its body. This silver band side is cathode. Silver band side is cathode, and this side is anode. This circuit is in forward bias condition because anode is connected with positive terminal and cathode side is connected with ground. So this diode is now in forward bias condition. This is ammeter to measure the diode current or circuit current, to measure the diode across voltage. Now we will construct our circuit diagram in project board. This one is project board. First we want to measure the supply voltage. This one is multimeter. Now our multimeter is in volt range, millivolt range, and it is in DC mode. And this is now AC mode. This one is DC mode. Now we want to change the range in. Now it is in volt range. This one is power switch. Power is on. Now it is in 0 volt. It was in 0 volt. This is ground. This one is 0 to plus 15. We can increase voltage by using this knob. This one is ground. This one is 0 to minus 15. We can increase voltage by rotating this knob. Black probe in ground and red probe in 0 to plus 15 point. Now voltage is 0. I am rotating the knob, voltage is increasing linearly. Yes, it is increasing linearly, and maximum voltage is 15.6 volt. Okay, our project board is in good condition. Take on diode. This is anode, this is cathode side. I insert it here. This one is project board. I insert my diode in project board. Positive terminal in anode side. Then I want to connect ammeter as per circuit diagram. First 0 to plus 15, then anode, then anode. Then I have to connect on ammeter. Ammeter positive here. Now another terminal just insert here, then on resistor R, then opposite terminal of resistor directly connected to ground. I have to connect on voltmeter. I will use this multimeter and use as a voltmeter. Red probe in anode and black probe in. Okay, this one is our complete circuit diagram. This is voltmeter. I power on, then voltage is 0, current is 0. I am rotating this one. Voltage is 0.1 on, current is 0. Voltage is 0.21, current is 0. Voltage is 0.24, current is 0. Voltage is 0.33, current is 0. Voltage is 0.42, current is 0. Voltage is 0.46, current is 0.1. Voltage is 0.47, current is 0.2. Voltage is 0.49, current is 0.25. Voltage is 0.5, current is 0.3. Voltage is 0.52, current is 0.4. Voltage is 0.53, current is 0.45. Voltage is 0.54, current is 0.5. Voltage is 0.55, current is 0.7. Voltage is 0.55, current is 0.8. Voltage is 0.56, current is 0.8. Voltage is 0.56, current is
1 milliampere, and our selector is in 10. Voltage is 0.57, current is 1.2. Voltage is 0.58, current is 1.3. Voltage is 0.58, current is 1.3. Voltage is 0.58, current is 1.3. Now this is maximum voltage plus 15. Diode across voltage is 0.59 and current is 1.4 milliampere. For reverse bias condition, we will just change the diode polarity. All other arrangement will same. Change the polarity. Now power on. I am increasing voltage. Voltage is increasing, but there is no current. Voltage is increasing, diode across voltage is increasing, but there is no current. Voltage is increasing, but there is no current. Voltage is now maximum in our project board, but there is no current.
This is your lab sheet. Apparatus required, circuit diagrams, working procedure, data table, result and discussion. You have to draw curve here. Also, you have to answer some questions in your lab sheet. For task 1, you have to answer these questions.